Hello everyone. Last meeting we talked about angles associated with parallel lines. So we talked about parallel lines and a transversal line. So uh, just to do a recap, so parallel lines are just lines uh, with a symbol of two arrows here. So if you can see that one, that means that these two particular lines are parallel to each other. So again, parallel lines are lines that will never met. No matter how you extend them to the left or to the right, they will never met. And the transversal line is just a line that hits your parallel line. So we call that one as transversal line. So with that, we created certain angles uh, with the parallel lines and your transversal line. So the first one that we talked about was the corresponding angles. So for the corresponding angles, we use the pattern, the F pattern, to locate them. Okay, so uh, corresponding angles are always equal. So corresponding angles are always equal. So these are examples of the corresponding angles. So if you can see the pattern here, this is letter F. So you have here letter F. So this particular angle that you see is equivalent to the other angle. So both have equal equivalent measurement. And then the second pattern, again you have the inverted F, but still that is an F pattern. So corresponding angles would be this and this. And if you're gonna measure the two angles, they are equal. And for the third figure, if you can see, you can also create letter F from your parallel line and the transversal line. So again, this is your transversal line here. And the parallel lines, if you can see, there are these symbols. So again, that is just to indicate that these two lines are parallel to each other. And these two angles here, if you're going to measure that, they should be equivalent. Again, they're equal because they are corresponding angles. And then the other angle that we talk about are the alternate interior angles. And with that, we use the pattern of Z. So, uh, for example, in this particular drawing at the right here, so again, you have this transversal line on which you are the transversal line hits your parallel lines. So the parallel lines are this two lines here. And again, to identify that, if you can see this particular arrow symbol, that indicates that these two lines are parallel to each other. And the alternate interior angles are located here. So these are your uh, alternate interior angles, the inside angles. Okay, and alternate interior angles are also equal, so they're always equal. So to continue our discussion on the angle relationships in parallel lines and the transversal line. So let's take example number 2. So use the alternate angles and straight angles. So again, alternate angles. So for the alternate angles, we use the Z pattern. And then the straight angles. So straight angles, just a straight line. Remember that if you have a straight line, angle along a straight line would always be equivalent to 180 degrees. So we're gonna find the angles marked by different letters. So you have here the first figure, letter A. So again, you can always extend your drawing. So just to emphasize, well, the location of your parallel lines. So to locate that, again, with this arrow symbol, that indicates that this particular straight line is parallel to the other straight line with the arrow. So since the arrow is here, so that means that these two lines are parallel. And in the drawing, you can actually do that. Try to extend just for you to have a better view of the parallel lines. Okay. So now try to locate our transversal lines. There are actually two different transversal lines here. One is this one. So this is a transversal line because based on their definition, it's the line that hits your parallel lines. So this is one transversal line. The other transversal line is given by this line here. Okay, this is a separate transversal line. Okay, so again, you can extend the lines for you to have a better, again, just to have a better view of the different patterns that we use to indicate alternate angles, as well as your, well, previously we have corresponding angles, the F pattern. So let's say, for example, I want to get angle A. So angle A is this particular angle. So what is the measurement of this angle here? Well, we know that we can create a pattern. So let's see if we can have a Z pattern out from these two parallel lines. So from these parallel lines and the transversal. So is it not that this, and from this transversal, yeah, I can create a letter Z out from that. So is it not that the alternate interior angles would be angle A? So this angle A here, this is your angle A. So is it not that that angle A is an alternate angle with the angle of 47 degrees? So 47 degrees and angle A are alternate interior angles. And if they are alternate interior angles, it's not that they're just equal. So therefore, we can say angle A is 47 degrees. Again, the reason behind for that is that they are alternate interior angles. So now I know my angle A. Next would be angle B. So what would be my angle B? Well, angle B is this angle here. So it is the angle between this one of the lines of your parallel lines and this transversal, the green line that I made. Again, that would be this particular angle. So I want to get that measurement, but then again, uh, I can create a pattern Z from these lines. Okay, so is it not that, well, B and the 69 degrees are your alternate interior angles of this green transversal line and the parallel lines. So again, alternate interior angles are always equal. So I would say that angle B is equal to 69 degrees. So that's also 69 degrees. And now for angle C. So for angle C is this small angle here. So the angle that makes up these two transversal lines, the green transversal line and this yellow transversal line, or orange. Okay, so that particular angle. But is it not that angle C is lying along this straight line of the one of the parallel lines? Okay, and with that, this particular straight line, you have angle A, B, as well as C. So that is just a straight line. So again, this creates a straight line here. So always in a straight line, the angle is 180 degrees. So therefore, angle C is just 180 degrees subtracted with the sum of angle A, so 47 degrees, plus 69 degrees. Because again, angle C is part of that straight line there. So it's one of the angle that is along the straight line. So it must be that if you can get the sum of C, A, and B, it will give you 180 degrees. But it's just the same thing as taking the difference. So C is just the difference of 180 degrees subtracted with the sum of A and B. So if you're gonna take the sum of A and B, that would be 116 degrees, or C would just give you a value of 64 degrees. So this is just 64 degrees. So again, I combine the things that I know from the alternate angles or alternate interior angles, the Z pattern, as well as the straight angles. So let's take the second example here. We have this particular figure, and again, the first thing that you need to do is at least locate your parallel lines. So the parallel lines are again given the symbol of these arrows. So that means that these two lines here, so I can extend that. So this particular line and the other line, so I'm just going to extend that. This will give my my parallel lines. Now my transversal lines. So again, the transversal lines, or a transversal line, is just a line that will hit your parallel lines. So the transversal line here is this, which is given by the green color. So that's one of the transversal line. The other transversal line is this particular side, or this particular line here. This is another transversal line. Okay, so this would be a separate transversal line, and this particular symbol indicates that the length of this side, so the length of this is just equivalent to the other side. So if you can remember, if you have two sides, because essentially this becomes a triangle, so this whole thing here is a triangle. So if the two sides are equal, we call that particular triangle as an isosceles triangle. So an isosceles triangle, again, is a triangle with two equal sides and two equal angles. Okay, so no, using that information, again, we can say that if this is angle E here, is it not that I can also say that this is my angle E? So this measurement is also equal to that, because again, in an isosceles triangle, the two sides are equal. These particular angles also are equivalent. So angle E, which is located here, again, this side and the other side with equivalent lengths of the sides, that would be the location of the angle. So now we need to, based on the information that we have, so for now we're just given one angle, and that particular angle is located here. So the angle at this particular side, one of the interior angle of your triangle, of your isosceles triangle, that's 42 degrees. So let's say, how would we get angle D? Well, let's see if we can see a particular pattern that is related to that 42 degrees. Well, let's see. So from this, one of the parallel lines and the transverse line, and the other side of your parallel line, okay, you're creating a Z pattern, and Z pattern gives you the alternate interior angles. So from there, if that is 42 degrees, if this is 42 degrees, well, angle D is the alternate interior angle of that 42 degrees. So therefore, angle D is also equal to 42 degrees. Again, the reason behind that is that these two angles, the 42 degrees and D, are your alternate interior angles. Okay, and alternate interior angles are always equal. So now I know that angle D is 42 degrees. Okay, that's 42 degrees. And if that is 42 degrees, if you have noticed, from there, this is a straight line, and well, angle F. So if you want to know your angle F, so that is just coming from this line here and this particular line. Well, I cannot say that angle F would be uh, exactly 180 minus 42 degrees, because if you can see, you still have it's not lying, you still have missing this part here, this part of the angle. Okay, so therefore you need additional information out from that. Well, fortunately for us, we are given a triangle, so I'm just gonna redraw the triangular part of that drawing. So based on that drawing, this is my angle E degrees. But I can expect, since I'm given an isosceles triangle, so this is 42 degrees, and then again, since this is a isosceles triangle, that would mean that if these two sides are equivalent, these two angles from the base of this triangle here is also or they are equivalent, but we don't know that. However, even though we don't know that, but since this is an isosceles triangle, we know that the total interior angle of this triangle would be 42 degrees plus angle E plus the angle E, and the sum of which will give you 180 degrees. Or if you're going to simplify this one, this is just 42 degrees plus twice the 2e. Okay. 180 degrees. Or if I'm gonna solve for the angle E, so angle E, if I want to solve angle E, I'm gonna subtract both sides by 42 degrees. Okay, so doing that, this gives me 2 times angle E is equal to 180 degrees. Or I'm gonna divide both. No, this is not 180 degrees, but should be the difference between 180 and 42 degrees. So this is 138 degrees, but I gotta divide to both sides to get my angle E. So angle E, therefore, is just equivalent to angle E is 69 degrees. So therefore angle E in this particular diagram is 69 degrees. Okay, so this would be 69 degrees. So this particular angle, the inside angle here, is 69 degrees. Now you can use that information to solve for F, because remember, you now have this particular straight line. So this particular straight line contains the 69-degree angle, which is part of that isosceles triangle, and angle D is already given, which is 42 degrees. So angle F, therefore, is just equivalent to, same thing as what we did earlier, is just the difference of 180 degrees minus the sum of 69 degrees plus 42 degrees. Okay, so F is 180 degrees minus, again, you subtract with the sum of 69 and 42, which is 93. So F is equal to 180 minus 93. So that gives you 87 degrees. Okay. So in this particular example, I actually use the previous learning. Like I know that in an isosceles triangle, there are two angles that are equal. And how do I know that this is an isosceles triangle? Because of the two sides. So this side here would have an equivalent length of this particular side. And if you're gonna create the base of the triangle, the location of the two equivalent triangle would be this particular side and the other side. So if you can see, that is just the angle that is made from the base and the two equal sides. So that would be the location of the two equal angles. And again, in a triangle, always I know that in a triangle, the sum of the angle, or the sum of the interior angles, would be equal to 180 degrees. That's why it's the basis of my answer here in locating for the angle E. So if you're going to take the sum of 42 and the two angles of E, the sum would give you 180 degrees. So that's my basis. So let's proceed to the next page. You have here an important thing to note. So you need to note about this, that when a pair of non-parallel lines is intersected by a transversal. So if you can see here, these are the two non-parallel lines. Okay, so I think it's quite obvious that they're not parallel. However, if it is in a drawing, well, you cannot see the symbol, the arrow symbol that indicates that these two lines are parallel. So if a pair of non-parallel lines is intersected by transversal, again, in our case here, the transversal line, so still this is called a transversal line, okay, because it is just a line that intersect these two lines here. The corresponding angles, so the corresponding angles and alternate angles will not be equal. So they are not equal. Okay. So if you're gonna look at that one, A and E, supposedly, so if you can see here, A and E, the corresponding angles, there are still corresponding angles, this and this. That's how we locate the corresponding angles, right? Because this is letter F. However, since this is not a transversal line and parallel lines, or these are not parallel lines. They're created not by parallel lines. They are not equal. Okay, so B and F. So B and F, if you can see here, so that's a letter F pattern. Still, letter F, inverted F. B and F are still corresponding angles, but they are not equal in this case for the same reason that these are two non-parallel lines, as well as the alternate angles, which are not equal. So alternate angles here would be your uh, D and F. So if you can see the D and F, so that is a Z uh, Z pattern. If you can see here, this is your Z pattern, right? So therefore, your alternate interior angles are your D and F. They are not equal. So this symbol here is just a symbol for not equal. So they are not equal, as well as your C and E. So C and E are also considered as alternate interior angles, because if you can see there, you can create a Z pattern. So there is a Z pattern. However, they will not give you equivalent value. So again, the reason for that is that it is not between a transversal line and a parallel line. So these two lines here are non-parallels. So for these examples, both the corresponding angles as well as the alternate angles, they are not equal. Okay, so let's take another angle relationship. This time we have the co-interior angles. Okay, so co-interior angles, or the C angles. Okay, so our C angles, we call the pattern as letter C. So the C angles, we call them as co-interior angles. Okay, if you have a protractor at home, so I want you to measure these different angles here. So if you can see, these are letter C, essentially C, and then C, and then letter C, inverted C. Let's see a letter C. Okay, so you can pause this video for a while and then try to measure that and try to answer the questions. Okay, here. Okay, welcome back. So if you have done the measurements, you can actually get that the angle X and the angle O in the three figures here will add up to 180 degrees. Angle O and angle X will not be equal. They will not be equal. Okay. However, if you're gonna add the two, O and X, you can expect that the answer is equal to 180 degrees. So again, if you have O plus X, that should give you an answer of 180 degrees. O is not equal to X. So again, try to prove that one. Try to measure it out. Maybe it's not that accurate, but it should be close to 180 degrees. Okay. So let's take the third example here. So calculate the uh, measures of the remaining angles. Okay, so of this parallelogram. So this means that if you can see, you have two arrows. Okay, so that means that this particular line, so I'm just gonna exaggerate that one and try to extend. Okay, and the other line, this particular line here, opposite to that is, or these two lines here are parallel lines. They're parallel to each other. And if you can see this line here, you have this particular symbol, a single arrow. So the single arrow indicates that these two lines opposite to each other are parallel lines. Okay, so we just need to identify the angles. So we just have to identify the three angles. So I'm just gonna call this one as A, and then B, and then C. Okay. Try to remember that we can still use the things that we've learned in the previous sections, like the F pattern and the Z pattern. Okay, as well as the C pattern in this particular case, which is uh, again just the interior angles. Again, we know that if we're gonna take the sum, it will give us 180 degrees. So let's try to find if we can see a C pattern in this figure. Again, just try to remember that this pattern letter C here is made up of, or came from, it should be two parallel lines, and this is your, you can say that this is your transversal. Okay, so if you can see that, well, 45, we're only given this angle here, one of the angle of your parallelogram, inside angle, interior angle. So is it not that I can create a pattern letter C here? So therefore, to solve for A, is it not that A plus 48 degrees should give me 180 degrees? Or that tells me that A is just 180 degrees minus 48 degrees. Because again, that is coming from the fact that A plus 48 degrees will give me 180 degrees. So therefore, if I'm gonna solve for A is just equal to 180 degrees subtracted with 48 degrees. So if you're gonna do that, that gives me 132 degrees. So that means that A is just 132 degrees. Okay, and how about B? So you think we can solve for, or at least identify B, angle B, just using the co-interior angles? Well, remember that these two particular part of your letter C is coming from your parallel lines, and one side is coming from your transverse line. Okay, transversal line. So if A is 132, So that means that this is 132 degrees. Well, let's see if I can create another C pattern. Well, is it not that if I gonna do this, this, and this, essentially that is just letter C, right? So as I mentioned earlier, this two side here is coming from your parallel lines. So these are just two parallel lines and I have this transversal. So therefore, since A and B are co-interior angles, so again, basing from the pattern letter C, I can say that B is just 180 degrees minus 132 degrees, or that is just equivalent to 48 degrees. Okay, so that means that this particular angle here is just 100, no, it's 48. It is 48 degrees. Okay, so now for letter C. Well, for angle C, I can still make a case that I can create letter C pattern from that. So that would be this pattern here, that is still letter C, right? So C is just a co-interior angle of your 48 degrees. So that means that using the same uh, analogy as in getting for A and B, that means that C is just 180 degrees subtracted with 48 degrees. And that gives me 132 degrees. Okay. Although you can also make a case of using the other angle relationships that you know for parallel lines and the transversal. So uh, yeah, let's see. Can we have a letter F here? Well, no, we cannot get the corresponding angle as well as yeah, I don't think so. Or letter Z. Yeah, we can maybe letter Z here. We say that the other angle here is 132. So if you can see, but this one is the more direct way of getting using the co-interior angles and getting the different angles A, B, and C. But if you can see here, I can use a pattern of Z, right? So the pattern of Z tells me that, well, uh, this particular angle here is just the same thing as your angle A. So this particular angle here is just 180 degrees minus 48 degrees. The reason for that is, well, is it not that this is just a straight line? So if I'm gonna do straight horizontal line there, that is just a straight line. So that means the sum of 48 and this angle here should give me 180 degrees. So therefore, this particular angle here is just 180 minus 48, or 132 degrees. So 132 degrees. So that is just the Z pattern. Okay, but this is the more direct way. You can use the co-interior angles. So as a summary, we can get the following. So again, parallel lines, importantly, you're talking about parallel lines. Again, we use the symbol arrow for that. So in our drawing, we use this to denote parallel lines. Are intersected with a transversal line. So again, transversal line is just a line that intersect your parallel lines. So that would be your transversal, an example, transversal line. So these are the things that you can have. The corresponding angles are equal. Secondly, alternate angles are also equal. And lastly, the C pattern, co-interior angles are supplementary. So therefore, when you say supplementary, sum is 180 degrees. So supplementary means that sum is 180 degrees. So again, supplementary angles, these are just angles that gives you the sum of 180 degrees. So co-interior angles are not necessarily equal, but they have a particular pattern, and that is the sum is 180 degrees. Again, co-interior angles, we have the letter C pattern. Alternate interior angles, we have the Z pattern. And then for corresponding angles, we use the F pattern. So you can take note of that. Again, to identify the corresponding angles, it's letter F. I mean, the pattern is F. Alternate angles, it's Z. And then for co-interior angles, it's C. And if a transversal intersect two lines such that corresponding angles are equal, alternate angles are equal, and co-interior angles are supplementary, then the two lines are parallel. So if number one tells you that you have two parallel lines, so given two parallel lines and one transversal, the following corresponding angles are equal, alternate angles are equal, and co-interior angles are supplementary. So you can also make use of these three properties to prove if lines are parallel. Okay, so that is the meaning of the second statement here. If a transversal intersect two lines, so again, in the second statement, you're just given a transversal line that intersect two lines. So at the start, you don't know if these two lines are parallel. However, if the corresponding angles are equal, the alternate angles are also equal, and the co-interior angles are supplementary, then you can say that the two lines are parallel. So the lines, or the two lines that being intersected by a transversal line, you can say that the two lines are parallel. So at this moment, try to complete the assignment. Okay, to complete the assignment number 1 to 9. I expect you to submit your work until the end of this session today. So again, just make sure that you answered as many as possible, and try to submit them. So whatever you have done today, try to submit them at the end of the session. Okay.